So what's the molecular interpretation of internal energy? It's really nothing more than the energy of the atoms and molecules in your system. Okay, so it's a sum of potential energy, which depends on how they're located, where their positions, their relative positions, plus their kinetic energy, energy due to motion of atoms and molecules. Okay, so if your system does not interact with your surroundings, your internal energy is just constant. Okay, it's just by themselves. So any changes in potential kinetic and any change in potential energy just becomes a change, the opposite change in kinetic energy. Now, Q, okay, is the energy transfer due to heat flow that results from random collisions among atoms. Okay, so a hot and cold object in contact will eventually reach the same temperature because of these random collisions between the atoms. Your energy just gets redistributed. So it's random redistribution of energy. That's what heat flow is all about. Atoms in contact, they're always moving, they collide with each other, they just spread, the energy just spreads out. That's just the natural tendency for energy to just be dispersed. Okay? Work, on the other hand, oops, it's almost time to go. Let me just finish this. I've got a couple more slides. Okay. So let's look at this one. Adiabatic walls, we said, would be thermally insulated walls, right? They don't allow heat to flow between system and surroundings. An example of an adiabatic wall would be your thermos bottle. What do you have inside that thermos bottle? There's a vacuum in there. So why is it very good for insulating? Making things cold, keeping things hot. It doesn't transmit heat very well. Why? If there's a vacuum there, there's no atoms that can collide, and so see, heat transfer occurs due to collisions between atoms. So if there's no minimal collisions between atoms, then there's minimal heat transfer. Okay, so that's how a thermos bottle works. Styrofoam. What do you know about styrofoam? It's very light, right? There's a lot of air pockets in your styrofoam. So what do you know about gases or air? The molecules are far apart, so you're trying to minimize collisions between the atoms there. That minimizes the ability of your material to conduct heat. Okay, so that's how they work at the molecular level. What about work? Work, the way you interpret work is that that's the energy transfer that results from a concerted or a synchronized or an organized motion of atoms. Like when you squeeze something, the atoms in the wall are all moving in concert, you could say. Okay, it's not just a random collision. So it's collisions that results from a concerted motion of atoms. So that could lead to collisions and redistribution of kinetic energy among the atoms, and so that's how you transfer energy by work. Okay, and I think that's the last of the slides. Thank you.